Okay, so last semester we concentrated on right triangles. So we could use things like Pythagoras, SOHCAHTOA, things like that. So Pythagoras, SOHCAHTOA. So if you remember, that was sine of an angle equals opposite over hypotenuse. Cosine of an angle equals the adjacent side over the hypotenuse. And finally, tangent of an angle is opposite side over the adjacent side. Okay, so the problem with that is that not every triangle is right. Okay, so we have acute triangles, we have obtuse triangles. Not every triangle has a 90-degree angle. So what do we do when we don't have a right triangle? Okay, so the good news is we do have something we can do. The first thing is it's still true that all three angles in a triangle add up to 180. So we still have the triangle sum theorem. Okay, so that's still true. Now, the other thing though is we don't have Pythagoras anymore. We can't use it. Okay. We don't have SOHCAHTOA opposite over hypotenuse, things like that. We cannot use that anymore. Okay, but we can use what's called the law of sines and law of cosines. So what we're going to do in these notes and the corresponding videos is we're going to cover law of sines first. Now, law of sines is a little tricky. What happens with law of sines is we have one instance where it's really straightforward, and then another instance where it's not so straightforward. So you have two videos on law of sines. Okay, first one, the straightforward case. Second one, we actually call the ambiguous case. Then you're gonna have a third video on law of cosines. Okay, so we're gonna do law of sines first. So let's write down the law of sines. Okay, so the law of sines, what you're gonna do is you're gonna use it when you know two angles in one side Okay? You can also use it when you have what we call the ambiguous case, which is when we know two sides and an opposite angle. Okay? So that is abbreviated like this. Okay? So we'll handle that separately, but let's do the first case where we know two angles on one side. Okay, so the formula for law of sines is actually, it looks really long and it looks kind of complicated, but it's really not. It's a proportion. Okay? Remember, lowercase letters are sides of a triangle, and then uppercase letters are angles. Okay? Also remember, okay, and this is just kind of a standard triangle. So if I name the angles A, B, C, then the sides are going to be opposite. So like this. Okay, that's how we're going to do it. That's how we're going to label our triangles. Okay, we need to remember that because that is actually really important. Okay, so let's talk about the formula. So we have side A divided by sine of angle A is equal to side B over sine of angle B equals, okay, side C divided by sine of angle C. Now this looks really complicated because you actually have two equal signs, but you only need to set up a proportion, so you only need one. So when you actually use this thing, okay, you're only going to have something like this. This is what you work with. You don't work with the entire thing. Okay? All right. So what we're going to do is we're going to use law of sines to solve a triangle. Okay? Okay, so there's my triangle. Okay? So let's see here. Let's say this is angle A. So this would be side A. This is angle B. So this would be side B. Angle C, side C. All right, here we go. Let's say angle A is 108 degrees. Angle B is 22 degrees. We don't know angle C. We know that side A, is 20. We don't know side B, and we don't know side C. Okay, so since I know 2 out of the 3 angles, the first thing I'm going to do is I'm going to use triangle sum to find my missing side, or excuse me, angle. Okay, here we go. So we get out our calculator, which should be in degree mode, and we get 50. Okay, so now to find the sides, we're actually going to have to use the law of sines. Okay, so notice that I know angle A and side A. So that is going to be the one side of the proportion. Okay, so this is the proportion that I would use to find side B, and this is the proportion that I would use to find side C. Okay, so what I typically do is I write this out, okay, and then I stick it into my calculator. Now I can do that because of the calculator I have. You need to know what calculator you have, okay? So let's solve them both, and then we've done our first example. So cross. So we get 20 sine 22 is equal to B times sine 108. Now I'm solving for B, so what I'm going to do is I'm going to divide by sine of 108. Okay, so B okay, now I get, so B equals 20 times sine of 22 divided by sine of 108. Now my calculator can handle that calculation all at once, so let me type that in. And I get 7.87769. Okay, so let's round it to the nearest hundredth. So that would be 7.88. Okay, so go back and fill out my answer. Now we're going to do the same thing for side C. Okay. So 20 sine of 50 is equal to C sine of 108. Now to solve for C, we're going to divide by sine of 108. Now notice how it looks very similar. Now, the temptation for some students is to use Pythagoras, but Pythagoras only works for right triangles. So please, 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 please remember that this is not a right triangle. You cannot use Pythagoras, okay? So Pythagoras is off limits for this triangle. Okay, for that one I get 16.11. And I did round. Okay, also please make sure your calculator is in degree mode. So, okay, so what we're gonna do is we're gonna stop right there, okay? And then we will cover the ambiguous case in another YouTube video, okay? All right, see you soon.